Hey guys, hope you're all doing good and welcome to a new video. In the last video, you must have learned how to install CONVERGE Studio. In this video, what we are going to do is we are going to set up a very simple flow problem and we are going to simulate it using the CONVERGE flow solver. So the first thing you need to do is open up the start menu and then type in CONVERGE to open up CONVERGE Studio, and then we are going to click on new project. So before we get started, I wanted to give you a quick walkthrough of the graphical user interface. Now on the left hand side, you basically have geometry editing tools. So anything that you have to do with creating, editing and deleting the geometries, you go to the left hand side. In the center, you basically look at the geometry. So that is basically your 3D view. That's where you manipulate the geometry, you zoom in, zoom out, pan, that type of stuff. And on the right hand side, you have everything to do with the case setup. When I say case, I'm talking about a simulation. So anything that you have to do with respect to the simulation, it has to go on the right hand side. Now in the middle bottom, there is another section which is basically your log window. Say that you're making a mistake when you're setting up the simulation. CONVERGE Studio tries its best to basically let you know what mistake you're making. And typically you would be able to click on a mistake and it should take you to the area where the mistake has occurred. Alright, now before we get started, I quickly wanted to do a quick walkthrough of the navigation tools. So to do this, what we are going to do is we are going to go to create and a geometry. Now if the geometry window is not visible, or say you accidentally closed it, oops, then you need to go to view and then you need to click on geometry. Alternatively, the shortcut key is Ctrl G, so I'm going to do that. I'm going to press Ctrl plus G, and then you can see that the geometry dock is now visible. Now sometimes what happens is when you're clicking, you might accidentally click and you might just drag it out. If that happens, what you should be able to do is you should be able to just click on this little dock icon here, which is basically called attach or detach. So if you click on this once, you're able to detach it. So just move it to a place and then click on attach and it's going to attach there. Alright, hope that makes sense. So I'm going to go to create. I'm going to go to create shape and then I'm going to create a box. And then let's click on create. This is just going to create a box. Now what I want all of you to do is I want you to press Ctrl and hold down Ctrl and then use the left mouse button to rotate the geometry. Right, you can see that I'm rotating the geometry, and then I can use Ctrl again, I'm holding on to it, and then I'm using the middle mouse button to pan the geometry. And finally I can use the middle mouse button or the scroll wheel to zoom out and zoom in. Right, now say that you don't like this option of holding down to the Control key. Sometimes you don't like it. I'm used to it, you might not. So go to options and then click on mouse, and here you have this option. You can say that, hey, I don't need a Control key. When you do that, you can just use your left mouse button and you can rotate the geometry. I am personally not a fan of this option. I like using the Control key. I would highly recommend this option unless you are used to some other settings from some other CAD program. Alright, so this is really important. So if you're able to rotate this geometry, then you should be good. Now what we are going to do is we are going to create a simple channel flow, right? So the idea is very simple. We create the geometry first and then we set up the simulation. So for this we don't need this geometry. So what I'm going to do is I can do an undo, right? So let me do Ctrl Z and you can see that the geometry has disappeared. Now remember, the only thing that I did before this was create the box. So when I clicked on Ctrl plus Z, or you can go to edit and do undo, you will be able to delete the geometry. Now if you accidentally did something else, like meaning you created two boxes and when you press Ctrl plus Z, it's just going to delete one of those boxes, right? If that's the case and if you feel like you're lost, that's fine. What you can do is you can just close the project, open up a new project. That's it. Alright, so now let's get started. So let's go to create and we are going to create a shape. I'm going to create a box and I'm going to say that the center of the box is 0.05 and I'm going to say that along Y and Z the center is 0, 0, and this is the dimension. Along X it's 0.1 meters long, along Y it is 0.01 and along Z it is 0.01 as well. Now note that there is no reference to the units. Well, that's because CONVERGE uses the SI units. So CONVERGE assumes that whatever you're typing here is in meters. So this is something that's very important to understand. So with this, click on create. Now you've created your channel, right? So a channel is basically like a rectangular duct through which flow is going in, along the x-axis, and it's going to come out. Alright, I hope that makes sense. So now you can see that the geometry is made up of triangles, and that's basically the fundamental entity in CONVERGE. In CONVERGE, every part of the geometry is assumed to be a triangle. So for example, what I can do is I can make sure that I'm basically in the cursor pick option, and I'm basically going to the entity mode, and I'm selecting a triangle, and you will see that I'm able to select a triangle. Right now, the selected triangles appear red in color. If I hit escape, they're going to get unselected. So let's try it one more time. Select two triangles, escape, we have unselected them. So now what do we want to do? Well, the idea is you have a lot of triangles. You have to group these triangles together to create something called as boundaries. That is your fundamental step in CONVERGE. So first, let's go and create some boundaries. So let's go to boundary, and we're going to go to flag, and this is where you create some boundaries. So if you click on this plus button, you can create boundaries. So for example, if I click on OK, you can see that the boundary has appeared. Let's click on plus again and click OK. Boundaries have appeared. Now say that you want to create more than one boundary at a time. You click on this plus, click on create multiple boundaries. Now note that every boundary is getting a boundary ID. So for example, boundary 1 has an ID of 1, boundary 2 has an ID of 2. Well, if I want to create 2 additional boundaries or 3 additional boundaries, I can just change this number to 3, and if I click on OK, you will have boundary ID starting from 3 all the way up to 5. So these boundaries are basically something that would be meaningful for you. For example, if this is a rectangular duct and the flow is coming through these 2 triangles, that's going to be your inlet, right? So what I can do is I can select boundary 1, select these 2 triangles, and click on apply. So this needs to be your inlet. So I can select boundary 1, I can then do right click, and I can just type in inlet, right? So similarly, what I can do is I can rotate my model. I'm using the control key for this, selecting these 2 triangles. I can add them to boundary 2, and what I can do is there are 2 ways. I can use the F2 option to rename the boundary, or I can right click. I'm going to call this as outlet. Now this right here is a top wall, right? This wall is on the top, so I'm selecting these 2 triangles, adding to boundary 3, and these 2 are also basically part of boundary 3. So what can I name boundary 3? Well, it's basically my top and bottom walls, right? So I'll just call it as top hyphen bottom hyphen walls, right? You can give any naming to it. Now I would stay away from using like crazy symbols like dollars and hash. It might be supported or it might not be supported. If you feel like you want to use like a symbol, you either use underscores or hyphen, nothing more. All right. So now we basically have 2 additional faces, right? So let's rename that. Now what I'm going to do is I'm going to go to boundary 4. I'm going to quickly select these 2 guys, add them to boundary 4, and I'm going to select these 2 guys and add them to boundary number 5. Now for boundary number 4, again I can right click, or I can use F2 to rename this. I'm going to call this as front 2D, and I'm going to select boundary number 5, and I'm going to call this as back 2D. Now you might understand front and back, right? Because one is on the front side and the other one is on the back side. But why 2D? Well, what we want to do is we want to run a 2-dimensional simulation. Now I understand that the geometry is 3D. We are going to pretend that this geometry along the z-axis has infinite length, meaning you don't have to simulate the flow entirely on the 3D geometry. You can just take any 2D slice and the flow pattern is going to repeat itself again and again, right? It's basically like you have a really large cake, right? If you have a really large 3-layered cake with cream in between, you make a slice anywhere, it's going to look the same, right? So it's kind of like that, where you basically create a slice and you're saying that, okay, I'm just going to simulate flow in that slice. But in order to identify that slice, you need to select the front and back of it, right? And that is the direction which you are trying to ignore, correct? And that is why you're selecting the front and the back side. I hope that this makes sense. If it doesn't, feel free to let us know. So we have basically completed setting up this model completely. Now the other thing that I want to look at is I want to enable the normals. What is a normal? Well, you see that you have a geometry, right? Any geometry has a normal vector, correct, which basically points perpendicular to it. Now in order for us to run computational fluid dynamic simulations, the normal should point towards the fluid. Now in this case, where is the fluid? Well, it's going to go inside the geometry, right? So in that case, the normal should point inside. So I'm going to go to transform, normal. I'm going to just select one triangle where the normal is in the opposite direction. Well, I could have selected any of these triangles. I'm picking this one. You might maybe pick something else. But pick a triangle where the normal is pointing incorrectly, which in this case is outside the geometry. And let's click on apply. When you do this, the geometry is perfectly clean. Well, how do I know if it's perfectly clean? Well, I know it from experience. But how can you be sure? Well, that is where you have something called as the diagnosis tool. So if you see here on the bottom right corner, you have something called as diagnosis. This basically checks your 3D geometry for errors. What type of errors? Well, it's going to basically look for intersection errors, open edges, non-manifold edges, normal orientation, and isolated triangles. So anything that's being checked for is going to be looked for, right? So if there are open edges, then you will basically see them and they're not allowed. You need to fix them. Similarly, intersections are not allowed and you need to fix them. In this case, let's click on find, and you can see that there are no errors, and that's why there's a green tick mark, which means the geometry is perfect. Now that's kind of reasonable. Now that's kind of what you would expect because the geometry is so simple. But since this is your first simulation, you need to make sure that you're following this. So let me click on clear. Now that I've cleaned up the geometry, what do I do next? Well, I need to set up the simulation, right? I need to say that a particular fluid is actually flowing through this. Now, before I do that, what happens if I accidentally close the diagnosis? Well, you can go to view and you can click on diagnosis doc. The shortcut key is Ctrl+D. Now, for some of you, you will actually notice that the diagnosis doc is on the other side. Now, this can happen. Notice how I have diagnosis and geometry on the left hand side. You can arrange this once you are used to a particular layout. Do not change the layout if you're not comfortable with it. So let's go to window and I'm going to click on restore default layout to get my previous layout. You can see that the diagnosis doc appears here and this is what I want. So now let's set up the simulation. So I'm going to go to case setup. Now this is basically a very nice wizard type of an interface that CONVERGE Studio provides us. So let me click on begin case setup, and since this is a generic flow and this is not an IC engine flow, I'm going to select this and I'm going to click on done. When you do that, CONVERGE basically gives you a list of steps that you need to follow. You need to start with the materials, the simulation parameters, boundary conditions, initial conditions, and so on. So now let's start one by one. Let's click on materials. Now in this case, we are just assuming that air is actually flowing through this particular model. So I'm just going to say that there is no reaction mechanism. I'm going to say that there is a predefined mixture which is air, and I'm going to click on apply. And it says that do you really want to overwrite gas.dat, mech.dat and therm.dat by loading predefined mixture air? Sure. Let's click on yes. And let's click on done. So when you do that, you can see that the reaction mechanism box has disappeared. Now global transport properties contains the turbulent Prandtl and Schmidt numbers. At this point, don't worry about these two parameters. We are not going to be touching them. So let's just click on OK. The other thing that you can do is you can just right click on it and click on validate if you don't wish to set up something. So what do I do next? Let me go to run parameters, and here I'm running a transient simulation, full hydrodynamic and compressible. I'm just going to say that this is a pressure based steady solver, and I'm going to click on OK. And when you click on OK, it's going to ask you a bunch of questions like, do you want to load the default tolerances for the various options? Just click on yes. And then it's basically asking, do you want to load defaults for non-engine applications? Yep, well, absolutely. When you do this, you can see that there's a green check mark. Now at this point, you might be wondering what these default tolerances are. Don't worry about them right now, because at this point, we are just interested in running a simulation so that we can post-process it, so that we can check if we have installed all the software tools correctly. So at this point, please don't worry. So now let's go to simulation time parameters. We are going to say that the start time is 0 cycles. That's when the simulation starts. And the end time is basically 15,000 cycles. For the initial time step, I'm going to put in a value of 1e minus 9. And that is going to be my minimum time step as well. And my maximum time step is 1 second. Now, if you do not understand the concepts of time step, don't worry. You should be able to understand this once the theory lectures on basic CFD is covered. So at this point, just type in the numbers that we are showing you on the screen. So let's click on OK. Then solver parameters, nothing's going to be changed here. In fact, this is one of the things that CONVERGE automatically sets up. So we don't have to worry about this at all. So let's click on OK. So then we are going to be defining boundary condition. Now defining boundary condition is very important in any CFD simulation. At the end of the day, when you're running a CFD simulation, you're solving some fundamental mathematical equations called as the Navier-Stokes equations. These are partial differential equations, and in order to solve these partial differential equations, you basically need to provide a starting point and boundary values. The boundary values are called as boundary conditions and the starting point is called as the initial conditions. So at the inlet, what I'm going to say is, I'm going to say that that's an inflow boundary, where I'm going to say that the pressure is basically 1 pascal above 1 bar, right? So that's 1, 0, 0, 0, 0, 4 zeros and 1, right? So I believe that's 1 pascal above 1 bar. And what's the fluid that's coming through inlet? Well, that's going to be air. So what about outlet? Outlet is going to be an outflow boundary, and the pressure at the outlet is going to be 1, 0, 0, 0, 0. So that's 1 bar. So now let me accept that, and I can just click on inlet. I don't have to save this specifically because it automatically gets saved. So let me go to outlet. You can see that 1 bar is already there. At the inlet, I have 1 bar plus 1 pascal, and I'm going to say that this is a total pressure inlet, right? Notice that it's already checked in. And at the outlet, it's a static pressure outlet. Now the top and bottom walls are nothing but walls, right? And your front wall and back are going to be 2D boundaries. Now notice when you are selecting the walls, there is something called as law of the wall. Now this has got to do with turbulence, but with just a 1 pascal difference, your flow is more likely to be laminar. But why are we then getting turbulence parameters? Well, that's because under physical models, you can see that turbulence is being checked. So I'm going to click on physical models, and then I'm trying to see if I can uncheck turbulence, and clearly I cannot. Well, why is that? Well, that's because if I go to boundary and if I click on top bottom walls, the law of the wall reference is here. So I need to first break this. So I'm just going to say that this is a no slip wall. And let's click on validate, click OK.